Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA June 2023, Paper 1, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1a, work out 0.7 times 0.5. Okay, so whenever I'm doing decimal multiplication, I just multiply the digit parts together first. So I've got 7 and 5 there. When I multiply them together, I'm going to get 35. And then I'm counting the number of digits that appear after the decimal place in either parts of the question. So I've got 1 appearing there and 1 appearing there. So that's 2 altogether. So I'm going to have 2 digits appearing after the decimal place in my answer. So my answer is going to be 0.35. So 2 digits after the decimal place in the question, 2 in the answer, so 0.35. Okay, part B says work out 5/6 divided by 3. I'm going to do fraction division here. I'm just going to change 3 into 3/1. And then we're going to be using keep, change, flip, KCF. Keep the first one the same, that's 5/6. Change the divide into a times, and then flip the second fraction over. So the 3/1 becomes 1/3. Okay, then I can just go ahead and do normal fraction multiplication. 5 times 1 is 5, and 6 times 3 is 18. So it's going to be 5/18. So that 5 doesn't look much like a 5. Let me just rewrite that as a 5. And then part C says work out 27 divided by 0.6. Now again, I'm going to write that second one as a fraction, and I'm going to use fraction division. So 27 divided, well, 0.6 is the same thing as 6/10, which is the same thing as 3/5. So I'm going to rewrite that as 27 divided by 3/5. So keep that the first one the same, change the sign into a multiply, flip the second one over. So I've got 27 times 5/3. Okay, so how many times does 3 go into 27? It goes in 9 times. And then 9 times 5 is 45. So that's my answer, 45. Question 2, solve 2x is less than 26. So I've got an inequality here. It's a linear inequality. These solve the same way as equations. You just follow the same rules. If you had 2x was equal to 26, you'd be dividing both sides by 2. So that's what I'm going to be doing here. I'm going to divide both sides by 2. So that's going to cancel that and leave me with x. And on the other side, I've got 26 divided by 3, which is 13. So x is less than 13. That's my answer. X is less than 13. Question 3, work out the value of 3/2 squared. So when we've got an index on the outside of the bracket and things either multiplied or divided inside the bracket, then that power is what we say distributed to each of the terms inside. We say that indices are distributive over division and multiplication. So what we're going to get here is the same thing as 3 squared over 2 squared. 3 squared is 9, 2 squared is 4. So it's 9 over 4. Question's asking it as a mixed number though. So 4's into 9 go twice, remainder 1. So that's the same thing as 2 1/4 there. So 2 1/4 is my final answer. Yeah, always read the small print. Just check your answer, the format of the answer that it wants before you move on. Question 4, ABC, BD and BE are straight lines. Angle EBD is equal to 5 lots of angle ABE. Angle DBC is 3 lots of angle ABE. Work out the size of angle EBD. Okay. So I'm just going to go through this line by line and kind of piece together what it means. So I've got ABC, that's this line here. That tells me that, you know, that's like 180 degrees from there. It's a straight line. Okay, that's a useful fact because it means that all those other angles are going to add up to 180 then, doesn't it? Okay, so I've got ABC, so BD and BE. These are all straight lines, aren't they? Okay, good to know. Angle EBD, where's angle EBD? EBD, this angle here then. This angle here is 5 times angle ABE. Where's angle ABE? ABE. All right, now I don't know what this angle is down here, but I know that this other one is 5 times bigger. Okay, so but if I give this a value, let's say I call this one x, then this one over here is going to be 5 times as big. It's going to be 5x. Okay, and then I've got angle DBC, DBC. This angle here is 3 times as big as ABE. Okay, so this one is going to be 3 lots of x. Okay. Hopefully that makes sense. So then I've got 3 angles sitting on a straight line, and so I know the sum of them, don't I? I know they're going to add up to 180 degrees. So my x and 5x and 3x add together to give me 180 degrees. So 5x, 3x, and x, that adds up to 9x, doesn't it? 9x. So I've got 9x is 180. So then dividing both sides by 9, it's going to leave me with x is equal to 20. Okay, now it didn't ask me about x, it was something I introduced. What it's asking me for is angle EBD. EBD, remember, was this one here, okay, which is 5 lots of x. Okay, so if I know that x is 20, then angle EBD is 5x, which is 5 times 20. It's going to be 100 degrees then, isn't it? Okay. Question 5, 2 prime numbers are multiplied together. The answer is an even number between 50 and 60. Complete the calculation. Okay. Well, if it's an even number, then I know that one of them straight away is going to have to be the only even prime number that there is. 2, because otherwise all the other primes are odd, aren't they? And odd times odd would be odd and not even. Okay, so it's going to have to be a 2. And then I suppose the other one needs to be a prime somewhere between 25 and 30, doesn't it? Because when I multiply it by 2, I'm aiming for between 50 and 60. So half of 50 is 25, half of 60 is 30. So our prime needs to be somewhere in between. So what are the prime numbers between 27 and 30? Well, it's not a whole lot. It has to be an odd number, doesn't it? And it can't be 27 because 27 is divided by 3 and 9. It's going to have to be 29. So 29 is the prime number. 2 times 29, that is 58, which is an even number between 50 and 60. Okay, I think we're done. Question 6. Andrew and Bruce share some money in the ratio of 5 to 6. Bruce gets £96. Andrew gives a quarter of his share to Carl. Bruce gives 2/3 of his share to Carl. How much money does Carl receive? So I'm going to start at the top with this ratio. I know that Andrew and Bruce share the money in the ratio of 5 to 6. And I know that Bruce gets £96. Okay, so if I've got a ratio between Andrew and Bruce in the ratio of 5 to 6, and I know that Bruce's share is 96, then that is just a multiple of the base ratio, because 6 goes into 96. What's that? 16 times? Okay, so 16 lots of 6 is 96. So on the other side, 16 lots of 5, that's 80, isn't it? So that's going to be 80 to 96. So that's the amount that that Andrew and Bruce get. So Andrew gives a quarter of his share to Carl. So Carl's share is going to be a quarter of Andrew's share, which is 80, plus 2/3 of Bruce's share, which we know is 96. It was given in the question. Okay, so what's that then? 4s into 80 go 20 times. So that's just 20, isn't it? And 3s into 96, that goes 32 times. And then 2 lots of 32, that is 64. Okay, so he gets £20 from Andrew and £64 from Bruce, given a grand total of £84. So that's my answer, £84. Question 7. 2a times 3 times 5 squared is 600. Work out the value of a. You must show your working. Okay, so so this is 600 written as a product of its prime factors. We know everything apart from the power of 2. But we want to work it back out then. So just multiplying this outlook again. So 5 squared is 25 times 3 is 75. So we've got 2 to the power of a times 75 is equal to 600. So I suppose if I divide both sides by 75 then they'll cancel, leaving me with 2 to the power of a. And then 75's into 600. Is that 8 times? So 2 to the power of a is 8. Well, 8 is 2 cubed, isn't it? So 2 to the power of a is 2 cubed. So a must be equal to 3. Just comparing the indices there. So if the base numbers are the same, 2, 2, I can compare the indices and say that a is equal to 3. Question 8. Expand and simplify fully. 5 lots of 3x plus 4 minus 2 lots of x minus 1. So this is not double brackets, it's repeated single brackets. So we're just going to be doing multiplying out of single brackets twice and then collecting like terms. Okay, so the first single bracket is 5 lots of 3x plus 4. So multiplying both things inside the bracket with the 5, I'm going to get 5 lots of 3x is 15x and 5 lots of 4 is 20. Now just take care with the second bracket because I've got a minus 2 at the front, so we're going to multiply everything inside the bracket with negative 2. So negative 2 lots of x, that's just minus 2x. And then when we've got negative 2 times negative 1, negative times negative actually going to give me a positive value, isn't it? It's going to give me plus 2. Okay, so then I've got two types of terms. I've got terms in x and I've got numbers. So adding the terms in x together, 15x minus 2x is 13x, and 20 plus 2 is 22. And that's going to be my final answer then, 13x plus 22. Question 9. Erica tries to sketch the graph y equals 1 over x, where x is not equal to 0. Make 2 different criticisms of her sketch. Okay, well, now, you need to know the basic shapes of all the various curves that might come up in the paper. This one is called a reciprocal curve, and the basic shape looks like this. Okay, so if I just quickly draw it. So knowing what the basic shape is, I can clearly see what's wrong with this one. First off, she's got this part up here. It's in the second quadrant, isn't it? Whereas in the actual graph, it should appear down here. Okay, so what she's drawn, graphs that look like that with a 1 in the positive quadrant is going to be like 1 over x to a power like x squared or x to the power 4 to an even power. Then you get one on the top of the line like that. But when it's just 1 over x, it's going to be in the third quadrant and not the second. Okay, so I'm going to write that down. So negative half of curve should be below the x-axis in third quadrant. That's kind of two ways of saying the same thing. I'm not quite sure why I wrote both, but anyway, just being very clear. So the negative half of curve should be below the x-axis in the third quadrant. So the third quadrant, first, second, third, fourth. Okay, so the third quadrant is that kind of bottom left corner of the graph. So that's one of my criticisms. The next bit here is this bit up here. Look, it's actually touching the curve, whereas you can see on mine, it kind of gets close to the axes, but never crosses or touches. Okay, so I'm going to write that down. So graph touches the y-axis, but graph is undefined. at this point. Okay, so the graph touches the y-axis, but the graph is undefined at this point. Okay, so, you know, at the point where x is 0, this graph is essentially infinite, isn't it? It's going to be, you know, flying off to infinity. So, yeah, we say it's undefined at that point. We don't really like dividing through by 0. It's like why this bit here was excluded in the first place, so avoiding the fact that we don't want to divide by 0 and get an infinite solution. Question 10. Sunita is X years old. Beth is 1 year younger than Sunita. Joel is double Sunita's age. The mean of their ages is 5. How old is Joel? Okay. So we know that Sunita is X years old, and we know that Beth is 1 year younger than Sunita. So if Sunita is X, 1 year less would be X minus 1. And then Joel's age is going to be twice Sunita's age. So 2 lots of X is 2X. Okay. So to work out a mean, we add all the numbers up, don't we? So if we add all those numbers up, so x plus x minus 1 plus 2x, the sum of those is going to be 2x, x, and x, which is 4x minus 1 then, isn't it? Okay, so that's the sum. And then to find the mean, we take the mean score is the total divided by the 3 ages then, isn't it? Or the 3 of them that there were. So that's going to be 4x minus 1 over 3. Now, if the mean age is 5, what does that make the value of x? Well, I've got 4x minus 1 over 3 is equal to 5. So multiplying through by 3, so times 3 times 3, that's going to cancel, leaving me with 4x minus 1 on the left. 4x minus 1 is equal to 15. Okay, adding 1 to both sides. That's going to give me 4x is equal to 16, and then dividing both sides through by 4. That's going to leave me with x is equal to 4 then. So that's my solution. X is 4. Is it? No, it's not. How old is Joel? Read the question. Joel is double Sunita's age. So remember, Joel was 2x. So that's going to be 2 lots of 4 then. That's 8. So the answer is 8. You almost caught me out there, question. Question 11. The Venn diagram represents 100 items. So we've got 2 groups, A and B. So all 4 parts of that should add up to 100, like it says. So write down the probability of A intersect B. So A intersect B is the bit in the middle between A and B. That is A intersect B here. Let's say. So that's A intersect B. But we want the probability of A intersect B. So when we're working out a probability, it's successful outcomes. It will be the 13 people in that area divided by total outcomes. And if you remember, there were 100 items altogether. So this is going to be 13 from the bit in the middle divided by 100, which is the total number of items. And that's my answer, 13 100ths. Okay, now the next part there then says work out the probability of a complement. That little dash there means complement of A. And in real speak, that means everything not in A. Okay, so everything not in A then would be everything outside A. Okay, so it's all the bit on the outside plus the bit in B that is not in A. Okay, so in terms of the values, it's going to be the 48 and the 12. They're both not inside A. Okay, so the probability then is going to be the total outcomes not in A, which is the 48 and the 11, divided by the total number of outcomes. Okay, so it's the bits in the blue area divided by the total again. So 48 plus 11, that's 59. So my answer is going to be 59 100ths. Okay, and then finally it says what's the probability of A union B. So A union B is everything in A or everything in B, or both. Okay, so A union B is going to be everything in A and everything in B. So in terms of this question, it's those 3 values in the middle. Okay, so A union B is everything in A and everything in B, or everything in B, or both. And then so that is the 28 that's just in A, the 13 that's in A and B, and the 48 that is just in B, divided by the total. Okay, so those three bits came from the pink area, and the green is everything. Okay, so 28, 13, and 48, what's that add up to? So 48, 58, 61, 81, 89. So I make that 89 over 100. 12a, a times 10 to the n is a number in standard form, complete the inequality for the value of a. Okay, so this is the general form of a number in standard form, isn't it? This a part here, the proper name for it is the mantissa, and then this part here, this power of 10, and we call the exponent. So we're interested in here about what are the rules for the mantissa part of the number. Now the mantissa, it needs to be a number which is between 1 and 10. Okay, now it can be equal to 1. You can have 1 times 10 to a power. That would be in standard form. Can't actually be equal to 10, because 10 times 10 to the power of something, you could take a power of 10 out of it and go back down to 1 again. So it is greater than or equal to 1, but strictly less than 10. Okay? B times 10 to the n is a number 7,200 written in standard form. Work out b times 10 to the minus n. Okay, write down your answer as an ordinary number. Okay, so first off we need to work out what b is. So 7,200 written as a number in standard form. I would have to write this part of the digits down first. The mantissa part is going to be the, the detail of the number. It's going to be 7.2 as a number written between 1 and 10. And then what would I have to multiply 7.2 by to get 7,200? That would be multiplying through by 10, 100, 1,000, wouldn't it? Or 10 to the 3. So the exponent part is going to be 10 to the power of 3. So this number is 7.2 times 10 to the 3. So I'm guessing then that b is equal to 7.2 then. And in this part of the number, n is equal to 3. So then if I then want to write down b times 10 to the minus n, then that number would be 7.2 times 10 to the minus 3. What's that then? So when you write a number with a negative power, I kind of think of this as the number of zeros that I need to write. So I'm going to write 3 zeros ahead of the detail of the number, so 0.00, and then I'm going to write the detail, the mantissa part, written as digits. So that is 72. Okay, so that minus 3 means there are 3 digits in front of the mantissa, and then I'm going to get the mantissa part of the number appearing as my answer there. So I'm going to get 0.0072. Question 3a. Here is a number machine. X is fed into the number machine. It's multiplied by a, b is added to it, and y is the outcome. Show that when the input increases by 2, the output increases by 2a. Okay. So, if I put, rewriting this in function notation, here I've got a function in x, f of x. If I take my function in x and I feed x into it, the first thing that happens to that x is that it's multiplied by a. So I'm going to get ax then, aren't I, when it passes through that first box. And then b is added to it, so I'm going to get ax plus b come out the other side. All right, so that's the basic function I've given. They're putting the output in as y here, but I'm just going to stick with f of x for now, because then I can do things like this. Now if we want to increase the input by 2, then what I'm going to have to do is add 2 to x when I feed it in then, isn't it? So rather than feeding it x, I'm going to feed it x plus 2. So that is going to give me a lots of x plus 2 plus b, isn't it? So multiplying out those brackets, a times x and a times 2, that's going to give me ax plus 2a plus b then, isn't it? Okay. So now I want to work out what the difference is between those two functions. I want to know what the increase is from one to the next. So I can work out the increase by subtracting one from the other then, can't I? So what I need then is I need f of x plus 2 minus f of x. Okay, so f of x plus 2 we worked out to be ax plus 2a plus b, and we need to, from that we need to minus f of x, which is ax plus b. So just tidying up those brackets, I've got ax plus 2a plus b minus ax, and minus a plus is a minus, isn't it? Okay, so what cancels here? I've got a positive b and a negative b. I've got a positive ax and a negative bx, and I've got a 2a left. So that all reduces down to 2a, okay, which is what I needed to get. So I needed to show that the output increases by 2a, which I have. Okay, so f of x plus 2 minus f of x is equal to 2a as required. Question 13b, f of x equals kx squared, where k is a function. Kai says that f of 6 divided by f of 2 is equal to f of 3, because 6 divided by 2 is equal to 3. Is he correct? Show work and to support your answer. I don't think it is correct, because it would be correct if it was a linear equation, but it isn't. It's a quadratic, so I don't think it's going to work. Anyway, let's work it out and find out. What is f of 6? F of 6 is going to be k lots of 6 squared, or 36k. And f of 2 is going to be k lots of 2 squared, or 4k. So f of 6 divided by f of 2, that's going to be 36k divided by 4k. So that's cancelling. 36 divided by 4, isn't that 9? So that's equal to 9. So is it equal to 3? No, that's not the same thing as 3 then, isn't it? Okay, so is he correct? No, he's not. Kai is wrong. Don't forget to answer the question. Kai is wrong. Question 14. Here's a list of 11 whole numbers in numerical order. The lower quartile, median, upper quartile, and highest value are missing. We're told that the median is equal to 2 lots of the lower quartile. The upper quartile is 2.5 times the lower quartile. The range is 2 times the interquartile range. Complete list. Right, so where are these things? So the median is the one in the middle, and you can see then that the one in the middle is missing. It's there. That's Q2. The median is Q2, second quartile. The lower quartile is 1/4 of the way through the data. This one here is the lower quartile, Q1. The upper quartile is 3/4 of the way through the data. It's going to be here, Q3. So this last one on the end, that's the highest value, isn't it? Okay, so we should be able to work these things out from the information being given. So the median is 2 times the lower quartile, and the upper quartile is 2.5 times the lower quartile. So these two numbers are both given in relative to the lower quartile. So if we call this one x, then the median is 2 lots of the lower quartile, so it's going to be 2x, and the upper quartile is going to be 2.5 lots of the lower quartile, or 5 halves of it. So that's 5x over 2 then, isn't it? And we know the range is 2 times the interquartile range. Okay, so the interquartile range, that is equal to the upper quartile, Q3, minus Q1, which is 5x over 2 minus x. So what's that then? So x is 2 halves, so 5 halves minus 2 halves, that's 3 halves, isn't it? So that's 3x over 2. Now remember, it says the range is 2 lots of the interquartile range. So we know the interquartile range is 3x over 2. So that means the range then is going to be 3x over 2 times 2, which is just 3x then, isn't it? So the range is 3x. And so the highest value is going to be the lowest value plus the range, isn't it? Because the range is normally highest minus lowest. So if I know the lowest and the range, then the highest is going to be the lowest value plus the range. So it's going to be 5 plus 3x, or 3x plus 5. Right, so now we know basically what these values need to be in terms of x. We need to come up with some values of x that are going to actually work in this context then, aren't we? Okay, so let's have a look at the highest value to start with. The highest value is going to be the biggest number, isn't it? So this highest value up here is going to have to be at least as big, if not bigger, than the number next to it, 34, isn't it? It's going to have to be bigger than 34, or the same size as 34. So 3x plus 5, the highest number, is going to have to be greater than or equal to 34. Otherwise, it's not the highest number, is it? Okay, so then taking 5 away from both sides, I'm going to get 3x is greater than or equal to 29. So then x is going to have to be greater than or equal to 29 divided by 3. So, well, that's not a nice number, is it? That's like 9 and a bit. It can't be 9 and a bit. It's going to have to be greater than or equal to 10, isn't it? So the least value that x can be is 10. Okay. And the greatest value x can be, if you look at the lower quartile down here, it has to be that x is less than 13, and isn't it? So x also has to be less than or equal to 13. Okay, so we've got a range of different values that x could take. It could be 10, 11, 12, or 13. Now, does that work in the other situations as well? So I guess if we look at Q3, it's divided by 2, and we know that they need to be whole numbers, so it can't be an odd number. So possible candidates for x could be 10, it could be 12. They're the only two options then, aren't they, in the conditions we've got at the moment. So let's assume it was 10. Does that work out everywhere? So if it was 10, if x is 10, then the Q1 would be 10. That kind of fits, that's okay. Q2, the median would be 20. That's sitting all right there. Q3 would be, what, 50 divided by 2? It would be 20, 25. That would be too low, wouldn't it? So that one doesn't work because it's less than 28, which is next to it. So that doesn't work there. So let's try 12 instead. So x is 12. So then that would be 12. Q2 would be 2 lots of 12, would be 24. Q3 would be 5 lots of 12, 60 divided by 2, which would be 30. And then the highest value would be 3 lots of 12, 36 plus 5 would be 41. That all seems to work out. So I think that's what the numbers I'm going to go for then. So 12, 24, 30 and 41. They seem to all work out. Okay, so a little bit of trial and error there, using the known facts to try and work our way through to a solution that works in all four boxes. Okay, question 15. ABCD is a trapezium. All four sides are different lengths. AB is parallel to CD. The diagonals intersect at X. Okay. So we can see it's not drawn accurately, so you're not going to be able to measure this or with a protractor or a ruler to help you. You're just going to have to go on facts from your knowledge of geometry. So, right, triangles AXB and CXD are similar. Okay, so let's go and find that out then. So where's AXB and where's CXD? So AXB, and CXD. Are these mathematically similar? Now, if two shapes are mathematically similar, they'd have to have all the same angles, wouldn't they? Okay, now, is that true? Well, this angle here is definitely equal to that one, isn't it? Because they're vertically opposite, so that is true. Those two do match. And because AB and DC are parallel, then this angle here and this angle here are what we call alternate angles, aren't they? When you've got a pair of parallel lines and a line crossing them, then these two are what we call alternate angles. So those two are also equal. And by a similar logic, then this one and this one are also equal because they are also alternate angles in a pair of parallel lines. So all the angles in AXB are equal to all the angles in CXD. So that is true. Has to be true for all cases. Okay, so that's that one done. Triangles AXD and BXC are congruent. Okay, so let's have a look at where those triangles are. AXD. Where's AXD? AXD down here. This triangle, is it congruent to BXC? BXC, BXC, BXC. Okay. Now, are they congruent? Well, if they were congruent, then all the angles would be equal and all the sides would be equal. Okay. Now, I know one pair of angles is the same. So if you have a look at this angle here, that is going to be the same as this angle here then, isn't it? Because again, they're vertically opposite. So they share one pair of angles. But what about the others? They don't look like they're going to be equal, but we can't really go on looks. What we do know is that all the sides of A, B, C, D are different lengths. And therefore, this side and this side are different lengths. They don't match. Okay, they're definitely different lengths. Okay, now it could be that it matches up with one of the other pairs, but I don't think so. Now I think we could argue that, you know, if BC was parallel to AD, then this angle would be alternate to this one, like it is in the other example, and this one would be alternate to this one. But that can't be the case. So because in order for these two lines to be parallel, it would mean that the only way that could happen is if A and B was the same length as D and C, and we know for sure they are all different lengths. So that is a different length from that one. Okay, so therefore AD cannot be parallel to BC, and therefore A is not going to be equal to C and B is not going to be equal to D in terms of their angles. So I think we can confidently say that these are not congruent from the information we've got on the diagram. That's definitely not going to be able to happen. Okay, for it to happen, then the trapezium couldn't all be different lengths, and they are. Right, so that one definitely can't be true. Is angle ADB equal to angle BDC? Well, ADB is this angle down here. Is that one the same as BDC? BDC, that one there. Well, again, I think we can say that's definitely not true, because if it was true, so if these two angles are the same, we already said that this was the two-stripe one. That means that the angle down there, D, must be the same as the angle over there at B then, because that's also a two-stripe one from earlier, isn't it? And that means that DAB must be an isosceles triangle, because it's got two base angles that are equal. If you've got a triangle where two angles are equal, so DAB, if we're saying that that angle there is the same as that one, then that's saying that the triangle must be isosceles. Okay, and if the triangle is isosceles, it means that that side must be equal to that side, but that's a contradiction because we already said that all four sides are different. So it cannot be equal, because if it was, it's an isosceles triangle, and if it's an isosceles triangle, all the four sides are not different. It's a contradiction, so it cannot be true. Then finally, area of triangle ABC is equal to area of triangle ABD. So where's that then? Let's get rid of some of the yellow, because otherwise it's going to be super confusing. So then ABC, triangle ABC, this triangle, is that got the same angle area as ABD? I got that the wrong way around, but you get the idea. So those two triangles. That is definitely true, because those two triangles share a baseline. So that's the base for both of them. And the vertical height is the same for both of them, because this is a nice, these two sides are parallel. We know that the point D and the point C are going to be the same perpendicular distance or height from the base. So the h of those two is going to be the same, and therefore you've got a triangle with the same base, same height, same area. So it's definitely going to be true. Okay, quite a tricky question, that one. I think that's pretty easily the hardest question on this paper. A lot of geometric reasoning there. Some, especially like this one and this one, are quite tricky to puzzle out. Yeah, but true, not true, not true, true. Question 16, solve the simultaneous equations 2x minus 5y equals 13 and 3x plus 4y is equal to 8. So we've got a pair of linear simultaneous equations in x and y. So we want to try and cancel out or eliminate one of the variables. I'm going to go for y because one is positive and one is negative. Now, in order to eliminate them, though, you need to have the same amount of both. So if I call that one equation 1 and equation 2, in order to eliminate them, I need to have the same number of y's of both. Now, I can do that by multiplying equation 1 through by 4 and equation 2 through by 5. Okay, so multiplying everything from equation 1 through by 4, I'm going to get 8x minus 4 5s are 20, aren't they? So 20y is equal to 4 13s are 52. And then the second one, multiply through everything by 5. I'm going to get 15x plus 20y is equal to 40. Okay. Now, in order to eliminate y, we can do that by adding these two equations together, because minus 20y plus 20y is 0. They cancel each other out. Okay, so adding the other bits together, 15x and 8x comes to 23x, and 52 and 40, that adds up to 92. Okay, so then we just need to divide both sides through by 23. Hopefully it goes in 4 times, does it? 4 lots of 23 is 92, that's right. So dividing both sides by 23, I'm going to get x is equal to 4. Okay, so half done. We found the value of x, but we need to find the value of y as well. So substitute x equals 4 into equation, which one should we sub it into? I'm going to go for the second one because then it keeps y positive, into equation 2. So that's going to give me 3 lots of 4 plus 4y is equal to 8. So 4y plus 12 is equal to 8. Taking 12 away from both sides, 4y equals minus 4. Dividing through by 4, y is equal to minus 1. So the solution then is x equals 4, y equals minus 1. Now, before you move on, it's always a good idea to double check because it's quite a complex algorithm, this one. So what we're going to do is we're going to sub x and y back into the equation I didn't use. So I used equation 2 to find y. So let's sub them both back into equation 1. Just double check that they're working. So check in 2 lots of 4, 2x minus 5 lots of minus 1, is that equal to 13? Well, 8 minus 5, 8 plus 5 is equal to 13. That is true, isn't it? Okay, so I know it's true, so it works in equation 1, it works in equation 2. I'm pretty confident I got it right. Question 17, a solid hemisphere has radius x, a solid cylinder has radius 3x and height x. Work out the ratio of the total surface area of the hemisphere to the total surface area of the cylinder. Give your answer in its simplest form. You must show your working. Okay, so we need to work out the total surface area of these two shapes. Okay, now let's take the hemisphere first. The hemisphere is actually made up of 2 faces, isn't it? It's got the flat face along the bottom. So this face here, it's a circular face. And then it's got like the surface area of the sphere part, this kind of bit up here, the roundy kind of curvy bit. Now we've got a formula for the surface area of a sphere here, but this isn't a sphere, it's a hemisphere. So the surface area of a hemisphere is going to be half the surface area of a sphere. So this part up here, the roundy bit, is going to be, or the curvy bit, is going to be, it's going to have an area of 4 pi r squared over 2 then, isn't it? 4 pi r squared is the area of a hemisphere's curved surface, but we've got a half of that because we've got a hemisphere, so we're going to divide it by 2. Okay, so that's 2 lots of pi r squared, where the radius is equal to x. So that's going to give me 2 pi x squared. Okay, so that part is 2 pi x squared. Now for the other part, this part down here, the flat circular part, that's just going to be the area of a circle. Area of a circle is normally pi r squared, but this one has a radius of x, so in this case that's going to be pi x squared. Okay, so the surface area of the hemisphere is going to be those two things added together then. It's going to be the 2 pi x squared from the curvy bit, and the pi x squared from the circular part, giving you a total of, I've got two things that are the same, adding them together, that's 3 pi x squared, isn't it? Because 2 plus 1 equals 3. Okay, so that's the hemisphere done. Over to the cylinder. Cylinder has got 3 faces. It's got your 2 of the circular faces. So I've got this one at the top, and that matches with the one at the bottom. So I'm going to have, for this one, it's going to be area equals pi r squared. Now this time the radius is 3x, so this one has an area of pi 3x squared. So don't forget you need to square the 3 and the x, so that's 9x squared, isn't it? Okay, so that's the area of the circle. Now the curved part, this bit here, is just a rectangle, isn't it? It's a long rectangle. It's going to have a height of x, and it's going to have a length which is equal to the circumference of the original circle. Okay, so the circumference of a circle is 2 pi r, so that's going to be 2 pi r, which is 2 lots of pi lots of 3x. Okay, so then what is the area of that then? It's going to be those two things multiplied together. So 2 pi 3x is 6 pi x times x is 6 pi x squared. Okay, so then the surface area of the cylinder is going to be the top circle. It's going to be the circular part. I just noticed I made a mistake when I wrote that down. I forgot to put the pi in. It's actually 9 pi x squared, isn't it? My mistake. So then adding all that up then, so that's 9 pi x squared plus the other circular base. This bit here, it's got 2 circles, isn't it? It's that bit and that bit. So that's another 9 pi x squared. And then we've got the ribbon bit around the edge, this bit here, which we worked out to be 6 pi x squared, didn't we? So I'm going to add on 6 pi x squared. Okay, so notice these are all to do with pi x squared. So adding all the pi x squares together, 9, 9 and 6, 9, 18, 24, then doesn't it? It comes to 24x squared. Okay, so what do we want? We want the ratio of the surface area of the hemisphere to the surface area of the cylinder. Okay, so surface area of the hemisphere to the surface area of the cylinder, we work that out to be 3 pi x squared to 24 pi x squared. Now notice we've got a pi on both sides, so we can cancel those out. Notice we've got an x squared on both sides, so we can cancel those out. So we've got the ratio of 3 to 24 left. Dividing both of those by 3, I'm going to get the more simple version of the ratio of 1 to 8 then, haven't I then? So the surface area of the cylinder is 8 times bigger than the surface area of this hemisphere. Okay, 1 to 8, final answer. Question 18, 6 is less than the cube root of x, which is less than 7. Circle the possible values of x. Okay. Well, I guess we could cube everything and then re-look at it again. So if I cube everything, what's 6 cubed? 6 times 6 times 6. 6 lots of 36. It's 216, isn't it? So 216 is less than x, which is less than 7 cubed. Ugh, 7 cubed. I can't remember. I can never remember that one. 7, 49. 7 lots of 49. What's that? 343. Okay, so my value of x must lie between 216 and 343. Well, there's only one value there that does. It's the big one on the end, isn't it? So it's going to be that one, 290. Question 19, work out how many 5-digit odd numbers can be made up using these digits once each. Do not list them because it will take you forever. It will take you a long time anyway. So let's have a think about this through mathematically. So we've got the numbers 2, 4, 6, 7, 9. We want to work out a 5-digit odd number which uses each one of these only once. Now you can consider this as boxes that need to be filled. I've got 5 boxes that need to be filled. Okay, there's some restrictions on some of these boxes though. It has to be an odd number. Has to be an odd number. So there is a restriction on the final box, what we can put in here. We have to put in a number in this box, so my overall number ends up being odd. So I've only really got two choices for that one. It can be either the 7 or the 9 go in there. So I've got two choices for the last digit. Now, are there any restrictions on any of the others? No. But let's say I pick the 7, then that means for the next digit along, I've got 1, 2, 3, 4 choices. So let's say for the first digit, that means I've got 4 choices left to put in there, because I will have had to have picked the 7 or the 9 first to go in the last box. Okay, so given that I picked one already, that leaves me 4 choices. Now it doesn't matter if I pick the 7 or the 9. If I'd have picked the 9, I still got 4 choices left for the first digit of 9. It's got the 2, 4, 6 and 7 could go in there. Okay, so let's say I picked the 2, then I would have 3 choices remaining for my next box, and then I'd have 2 choices remaining for the next one and 1 for the next one. Okay, so the last one kind of just sorts itself out. So then the total number of numbers I'm going to get is I'm going to multiply all those together. Okay, so what's 4 times 3 times 2 times 1 times 2? 4 3 is 12, times 2 is 24, times 1 is 24, times 2 is 48. Okay, so it's equal to 48. So I suppose feasibly you could have written them all out. It's just going to take you a while to write out 48 numbers, making sure you don't miss any. Much better to do it mathematically. The answer is 48. Question 20. K, L and M are weights. Both of the scales balance exactly. How many M weights are needed to balance one L weight? Okay. So I suppose we need to make some equations, don't we, here? So on the left-hand scale, you've got 3 Ks and they are perfectly balanced out by 4 Ls. So from this first set of scales, we can say that 3K equals 4L. Okay, so that's my first equation that I've got. And then in the second set, I can see that K balances out with L plus 2M. So that's my second equation that I've got. So I've got 2 equations, currently 3 unknowns. Okay, so what I want to do is come up with an equation that has M's and L's in it. M's and L's. So in other words, I need to eliminate K. Okay, so you can see I've got a K here and I've got a K here. So I guess if I can make the second one match with the first one, if I get 3K on the end, I can plug the other ends of it together, can't I? So if I take equation 2 and I multiply up by a factor of 3 first, that's going to give me 3K equals 3L plus 6M. Okay, so then I can let's call that equation 3, and then I can equate equation 3. So I'll substitute equation 1 into equation 3. Okay, so then plug in my kind of 3K here and 3K here together. Then I can say that this part, the 4L here, must balance with the 3L plus 6M over here. Okay, so let's do that then. So let's do that. So 4L then must be equal to 3L plus 6M. So taking 3L away from both sides, I'm going to get L equals 6M. Okay, so 1L must be equal to 6M. Seems like a lot, but I'm guessing that must be right because I did the algebra and that's what it came to. So has that answered the question? How many M weights are needed to balance one L weight? Well, 6 of them then, isn't it? So the answer is 6. Okay, so answer 6. Question 21. Express x squared minus 6x minus 15 in the form x minus a all squared minus b, where a and b are integers. Okay, so in other words, they're wanting us to complete the square here, and that's what this technique is called. Having a look at the first 2 terms to start with, we can rewrite this as a square by taking the coefficient of x and halving it. So rather than having x minus 6x, I'm going to have x minus 3. Okay, so x minus 3 all squared, if you multiplied that out, you get x squared minus 6x plus 9. So we need to take that extra 9 away that we introduced. Okay, and then what I've written down now balances with the x squared minus 6x. And then I've got minus 15 on the end that I had before. So I need to kind of add that back in. Okay, so this bit here is a replacement for the x squared minus 6x, and I had the minus 15 on the end. Okay, so then just tidying that up a little bit, then I've got x minus 3 all squared, minus 9 minus 15 is minus 24 then, isn't it? Okay, so is that in the right form? A is 3, B is 24, seems to work, doesn't it? Okay, we're done there. Question 22, A is root 2, B is root 18, match each expression to its value. One has been done for you. So if A is root 2, then A squared is going to be root 2 squared, which is 2. That one's been done. So A plus B is going to be root 2 plus root 18. Okay, can we express 18 or root 18 as a multiple of root 2? Well, if you think about it, root 18 is the same thing as 9 times 2 rooted, which is the same thing as 3 root 2. So if adding root 2 to 3 root 2, that's giving me 4 root 2 then, isn't it? So that one there goes with 4 root 2. AB, so if I've got AB, then that's going to be root 2 times by 3 root 2. So root 2 times 2 root 2 is 2. 2 times 3 is 6, isn't it? So that one goes with 6. And then B over A is going to be 3 root 2 over root 2. They're just going to cancel. And that's going to leave you with 3 then, isn't it? So that's equal to 3. So that one goes with 3. All right. Question 23. Write 0.13 reoccurring as a fraction in its simplest form. Okay, so there's a trick to this. I'm going to use a little bit of algebraic jiggery-pokery. Let x be equal to our number, 0.13 reoccurring, which is a bunch of 3's after 1 like that. Then if I take that and I multiply it through by 10, I'm going to get 10x is equal to, everything's just going to move along one place, isn't it? So that's 1.33333 and so on. Okay? Now notice that if I subtracted these from each other, then 10x minus x is going to give me 9x on this side. On the other side, if I did a subtraction, that 3 is going to cancel with that, that 3 is going to cancel with that, that 3 is going to cancel with that, that's going to cancel with that, that's going to cancel with that. So essentially I've got 1.3 minus 0.1 on the other side, and 1.3 minus 0.1, that is 1.2. So I've got 9x is equal to 1.2. So dividing through both sides by 9, I'm going to get x equals 1.2 over 9. Not quite a fraction because I've got a decimal on the top. You can get rid of that by multiplying top and bottom through by 10. So I times this through by 10 just to get rid of the decimal. That's going to give me 12 over 90. Okay, and then I've got some factors that they share, isn't it? Both of those numbers are divisible by 3. So dividing top and bottom through by 3, just to cancel it down a little bit, that's going to give me 4 over 30. Oh, and I can do it a little bit more then. That's the same thing as 2 over 15 then, isn't it? So in its final form, it's going to be 2/15. Question 24. Points P, Q, and R, which we know is at 822, form a triangle. PQ is a horizontal line with P on the y-axis, and the angle PRQ is a right angle. The gradient of PR is 2. Work out the coordinates of Q. Okay. Right, so we've got quite a bit of information here, haven't we? We know the gradient of the line PR. Why don't we see if we can work out something about this line PR then. Okay, so we know the gradient of PR is 2. So the equation of the line PR is going to be of the form y is equal to 2x plus c, where c is the y-intercept, okay? Because the 2 comes from the gradient of the line, doesn't it? Okay, so if we know that, we also know that the line passes through the point R, which has coordinates 822. So if we plug those numbers into the equation, and the only thing we won't know there is c, isn't it? So replacing y with 22 and x with 8, you can see then that 22 is 2 lots of 8 plus c. 2 lots of 8 is 16. 16 plus 6 is 22, so c must be equal to 6. Okay, so therefore the equation of the line is, well, it's going to be y equals 2x plus 6 then. So now we know the equation of the line. We also know that p is at the point 0, 6, then, isn't it? Okay, so we worked out that the y-intercept was 6. So p is the y-intercept, so it's going to have a coordinate 0, 6. So now we just need to work out the coordinates of q. So we know that the height is 6, so it's something 6. We just need to know the x value now, don't we? Now, what else do we know? We've got this right angle up here. This could help us. Now, that tells me that the gradient of this line, RQ, is going to be the negative reciprocal of the gradient of PR then, isn't it? So, for the equation of the line RQ, its gradient, M2, is going to be the negative reciprocal of the gradient of M1. Of the first one, isn't it? So that had a gradient of 2, so that is going to be minus a half then, isn't it? So it's the negative reciprocal of the gradient of the other line. So therefore equation is going to be of the form y is equal to a negative a half lots of x plus c. Okay, and we know it also passes through the same point. It passes through 822 again, doesn't it? So we know it passes through 822. So subbing those numbers in, I'm going to get 22 is equal to minus a half lots of 8 plus c. So this one has an equation of, well, a c value of minus a half of 8 is negative 4. Adding 4 to both sides, I'm going to get c is equal to 26 for this one. So the equation of this line is going to be y is equal to minus a half x plus 26. Okay, now we want the value of x when y is equal to 6, because we already know the y coordinate of that point down there, q. So I guess all we need to say then is when y is equal to 6, then the equation is going to be 6 is equal to minus a half of x plus 26. Okay, adding half x to both sides and taking 6 away, I'm going to get half x is equal to 20, and then timesing through by 2, I'm going to get x is equal to 40. So that one there is going to be 46. So what is the coordinates then of x? Therefore coordinates of q is 40, 6. Okay, question 25. Show that 4 sine 30 minus tan 45 all divided by 2 cos 30 can be written as tan x, where x is an acute angle. So for this question we really need to know our exact values for sine, cos and tan. Handy way to remember it is, no, we need to know the ones for 0, 30, 45, 60 and 90. So for sine and cos, we're going to use the number 0, 1, 2, 3, 4 for sine and inverted for cos, 4, 3, 2, 1, 0, all over 2. Okay? So this is a bit complicated what I've written down here, but it's actually quite a useful way of just summarizing all the information that you need for the sine, cosine and tangent of those angles. I'll kind of go through it as I need it. So for sine 30, that's going to be 4, what is the sine of 30? So in my table here, I've got sine of 30, that's going to be 1 over 2, well the root of 1 over 2. You see that root symbol goes over the numbers on the top. So sine 30 from my table is root 1 over 2, which is just a half. Okay, so sine 30 is going to be 4 lots of a half minus the tan of 45. So when we're doing the tan, So if you want to do tan 45, then the tangent of the number is the sine divided by the cosine. So it's going to be the sine number root 2 divided by the cosine number root 2 from the table. So that's going to be root 2 over root 2, which is 1. So it's going to be minus 1 all over 2 cos 30. What's cos 30? So then cos 30 is going to be cosine of 30. It's going to be here, look, root 3 over 2. So it's going to be root 3 over 2 there. And remember, there are 2 of them, so it's 2 lots of root 3 over 2, like that. Okay, so we've done all our working out from the exact values. So now we just need to deal with the maths. So 4 lots of a half, that's 2. 2 minus 1 over 2 lots of root 3 over 2. Well, that kind of cancels out, just leaves you with root 3 on the bottom like that. So then this is equal to 1 over root 3. Now apparently this can be written as tan something. So the tangent of which angle is 1 over root 3? Well, remember, so if remember tan is the sine 1 divided by the cosine 1. So it would be root 1 over root 3. That's the same thing as 1 over root 3, isn't it? Which is 30. So that is the same thing as tan 30 degrees there. So all that boils down to tan 30. So where x is an acute angle, 30 is an acute angle. So it kind of fits, isn't it? So my answer is tan 30. Okay, let me just put a box around that so it doesn't get confused, my answer. So my answer is tan 30. Question 26. A circle center origin has circumference 20 pi centimeters. Q is a point on the circle. OPQR is a square. The perimeter of the square to the circumference of the circle is in the ratio of root a to pi, where a is an integer. Work out the value of a. You must show your working. Okay, so first off, with these sorts of diagrams, which you've got a diagram, quite a complicated one, and lots of wording, just check everything in the wordings on the diagram. I can see one thing, or a couple of things that are not. So the circle center O has a circumference of 20 pi centimeters. Okay, so the circumference is 20 pi centimeters. I'm just going to say C is equal to 20 pi. And then we know that OPQR is a square, so that means that these sides are all the same length then, aren't they? Okay, so that's quite important information. Right, so what can we derive from the facts that we know? So we know that the circumference is 20 pi, but we also know that circumference is equal to 2 pi r. So if 2 pi r is 20 pi, so if 2 pi r is 20 pi, then pi's cancel. That means 2r is 20, so r must be equal to 10, mustn't it? So the radius of this circle is 10. And that is OQ then, isn't it? That's the diagonal of that square there. That is 10. Okay? So we know that the radius OQ is 10, which happens to be that diagonal of the square. So probably from that we can work out what OP is then, isn't it? Because if I've got a triangle, which I know is 10, and I know that this and this are the same side, then I can use, so that's going to be like A and A then. So I can use Pythagoras Theorem to work out what that is. So the longest side, 10 squared, is equal to the sum of the squares of the other two sides. It's going to be a squared plus a squared there then, isn't it? So that tells me that 100 equals 2a squared. So 50 equals a squared. So then a is the root of 50 then, isn't it? So that side there is root 50. So then what is the perimeter of the square? The perimeter would be the 4 sides added together. So then the perimeter of the square, that would be equal to 4 lots of 50, root 50 then, isn't it? 4 root 50. Now I can probably simplify that down a bit, because root 50, that's like 25 times 2. isn't it? And the square root of 25 is 5, so that's the same thing as 5 root 2. So 4 lots of root 50 is the same thing as 4 lots of 5 root 2. So that's going to be 20 root 2 then, in a kind of more simple way of writing that down. So I've got the perimeter of the square, it's 20 root 2. Have I got the circumference of the circle? Yeah, that was given at the beginning. That was 20 pi, wasn't it? So then we've got the ratio then of... So the perimeter to the circumference is going to be 20 root 2 to 20 pi then, isn't it? Now notice they both got a 20 in it, which is handy, it cancels. So then that leaves me with root 2 to pi then as my final ratio then. So A is 2. So A must be then 2. Okay, just basically comparing what I've got here with this up here. Look. So A must be 2. Question 27. A journey has 2 stages. I've got stage 1 and stage 2, and I can see the distance, speed, and the time given for each of those in terms of A and B. It says show that the average speed of the whole journey in kilometers per hour is 2AB over A plus B. Now I feel there's going to be some horrendous algebra going down here looking at this question. Okay, so the average speed is going to be the total distance travelled divided by the total time taken, isn't it? So the total distance is going to be the two distances added together then, isn't it? It's going to be 30 plus 30. Well, that wasn't too bad, that was 60. And the total time taken is going to be 30 over A plus 30 over B. So then average speed is, you know, from the DST triangle, distance, speed, time triangle. So average speed is distance divided by time, isn't it? So the average speed for the whole journey is going to be the total distance travelled divided by the total time taken. So speed equals distance over time, which is 60 over 30 over A plus 30 over B. This is why the algebra is going to be fairly horrendous. Okay, right, so now in order to make sense of this, probably before I subbed it in, it would have been better to put this over a single denominator. So if I put that over a single denominator, that's going to be AB, isn't it, over a single denominator, and then that's going to be 30B plus 30A over AB, isn't it? Okay, so dividing through by a fraction is the same thing as flipping it over and times in. So I could say that's the same thing as 60 multiplied by that fraction flipped over. So AB over 30A plus 30B. Just trying to tidy it up so I can plug these two things together a little bit easier. So that's given me 60AB over 30A plus 30B. Okay, almost there actually. So you can see all of these things I could factorize 30 out of. So I could say, well, that is the same thing as 30 lots of 2AB over, and I can factorize 30 out of the bottom bracket as well, A plus B. And then those two things will cancel. And then that will just leave me with 2AB over A plus B then, as required. Okay. Yeah, so actually it wasn't too bad. But I can imagine that would throw a few people off when they first look at it, because you've got some denominators that are also fractions, which is not nice. Yeah. Anyway, we've got to the end. That's it. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.